Potassium oxide K2O. In this tutorial, we will explore the ionic bond formation in potassium oxide K2O. K2O is made up of two K atoms and one oxygen atom. As you now know, the first step is writing the electron configuration for each atom. Starting with K, potassium, it has 19 electrons, so the electron configuration is 2, 8, 8, 1. Oxygen has 8 electrons occupying 2 shells, 2 in the first and 6 electrons in the second shell. The second K has the same electron configuration as the first, with electrons occupying 4 shells. K has 1 electron in its outermost shell, while O, oxygen, has 6 electrons in the outermost shell. So the first K atom, the first potassium atom, will lose 1 electron, and this electron is transferred to oxygen, and the same for the second potassium atom. So electron configuration will be the following. For K, it will become K plus because it lost 1 electron, and the electron configuration is 288. Close the bracket and add the positive charge indicating loss of electrons. Oxygen becomes O2 minus because it gained 2 electrons. Its electron configuration is 2, 8. Close the bracket and add the 2 minus charge indicating gain of 2 electrons. The second potassium is the same as the first. It lost 1 electron, so it's K plus, and the electrons are now 18, occupying 3 energy levels. This is the result of electron transfer from potassium to oxygen. Each potassium atom lost 1 electron, and oxygen gained both electrons, and this transfer of electron forms the ionic bond of potassium oxide K2O.